Alright guys, welcome back to this video. So in this video, we'll be talking about exponents. In other countries, you may heard them as indices. You may have heard of them as indices. So these are the synonyms. So before we get to any of this, we will need to know the parts of an exponent, or power we call it. So an exponent is an expression, or power is an expression written in the form of a to the power of b. The bottom number here, we'll call it the base. I write b for base. And the above number here, we'll call it exponent. So I guess I'll label it as e. And together, combined, we'll call them a power. So that's it. And there are certain laws. Well, before we get to the laws, I will need to show you what an exponent actually means. So we'll use 2 to the power of 3, or 3 cubed. So to evaluate an exponent, because I want to show you what it is, you have to copy down the base, and you can multiply. Well, like it says 3 here, right? So you have to multiply itself by 3 times. Multiply by itself 3 times. So 2 times 2 times 2, 2 times 2 is 4, 4 times 2, that's 8. Let's take a look at another example. So 4 to the power of 4. Copy down the base, as always. And since it says 4 here, we'll multiply itself 4 times. 4 times 4 times 4 times 4. You could use a calculator if you want. So 4 times 4 is 16, and 4 times 4, that's another 16. So 16 times 16, that's 256. So that's just another way to do it mentally. Now let's get to the laws. Laws are actually just tools that can make evaluation or simplification, or I guess factorization, easier. And these will certainly come out in the exams. These are hard questions, so you need to pay attention. So the first law is the zeroth power law, which states that anything to the power of 0 is 1. And I will show you the proof if time allows it. So let's look at more examples. So, that's a terrible looking 25. So 25 to the power of 0, that is 1. 100 to the power of 0, you guess it, that's also 1. And stay tuned, because in the next couple of videos, I will actually prepare some practice problems for each of these laws, except for the 0 power law and the 1 power law, the first power law, which I will show later, since these two are really simple. So now let's take a look at a more confusing example, but I guess it's not confusing, it's just a little bit tricky. Let's say you're asked to evaluate this monstrosity, x times y times z, all to the 0 power. If you see a 0 as an exponent, it's just 1. For goodness sake, it's just 1. You don't need to overthink it. Alright? So let's move on to the next law. This is the first power law, the next one. So it states that x, I will use x again, I love x, okay? X to the power of 1, anything to the power of 1, it's itself. It doesn't change anything. It's like the water bottle from Minecraft. You drink it, nothing happens. So I use 256. You know what? Let's add 1,000 for good measure. For good measures. To the power of 1. It doesn't change. It is still 256,000. So you see something like, let's do something ridiculous like x to the, you know what, x, y, and I'll use log or something. Okay, this is just getting ridiculous, but it's just to show you how these laws can make stuff easier. So if you see a 1, don't overthink it, it's just x, y times log of z. And if you guys haven't heard of a logarithm, don't worry, I'm planning to make a video on it soon, so stay tuned for that as well. So let's move on to the next law. The next law is the negative power rule. So sometimes you may come across something like x to the power of, say, -2. What does this mean? You can reverse multiply, right? Well, actually you can. It's repeated division. So that you don't necessarily need to divide that many times. There's a simpler way to do it. So it's just 1 over the bases. You will keep the same. You keep it the same. But for the power, for the exponent here, we will change it from a negative sign to the positive sign. So I guess the 2 is happier down there, so it's positive, right? So that's another way you can sort of grasp it into your brain, I guess. So let's take a look using some real examples. So let's use 5 to the power of negative 3. So 1 here, 1 over, the base is the same, negative 3, it becomes happy in the bottom, so it becomes a positive 3. And if you want to evaluate it, 5 to the power of 3, that's 5 times 5 times 5, that's 1 over 125. And if you're wondering how I got this answer so quickly without using a calculator, it's just experience, okay? That's how much I love math, okay? So let's generalize this. So let's say, actually let me use n to the power of negative x. So 1 here, base is same, negative x set to happy, so we have an x here. And the n and the x here, they can mean any number. They are just placeholders for any other values. So because they are variables, right? So the textbook may write something like x to the power of n, x to the power of y, but just know they are the exact same thing. So just don't overthink it, alright? In math, don't overthink. So let's move on to the next law. The next law is the product rule. It's the product rule. So let's say you come across something like this: x cubed times x squared times x cubed. If you see a product indicated by the multiplication sign here, and if the bases are the same, so x and x, they are the same, right? So that checks out. But the bases, for the power doesn't necessarily need to be different. It just, as long as the bases are the same. If you see the bases are the same and they are being multiplied together, you can actually add the powers together. So 2 plus 3, that's 5. And of course, there's another one for division. So let's say you have x cubed divided by x squared. The bases are the same, and if the bases are the same and it's being divided, so in the multiplication part we use addition, right? So the opposite of that is subtraction. So division, we use subtraction. So 3 minus 2, that is 1. And x to the power of 1, anything to the power of 1, as previously stated, it's just x, it's just itself. And for division, there's another rule of thumb that you should know. If the larger power is at the bottom or the denominator, you have to subtract from the bottom to the top, right? But instead of having your final power on the numerator, you have it on the bottom, the denominator. So keep in mind, if you are subtracting from bottom to the top, please put your final power or your final expression in the denominator. So let's take a look at a more confusing example. So let's say you are asked to simplify this: x cubed y times x squared y squared. If you see multiple variables, since we have x and a y, we multiply from the same variable to the same variable. So x will go to x, y will go to y. So x will go to x, right? So the bases are the same. 3 plus 2, that's 5. And y times y, if you see nothing here, that is just 1. Because y to the power of 1 is just y. So it's kind of like an invisible thing. So 1 plus 2, that's 3. So that's how you would evaluate it. Same goes for division. Same variable to the same variable. X to x, y to y, z to z. For goodness sake, please don't make stupid mistakes, alright? Don't be like me when, like 3 years ago. And let's move on. This, I'll call it power of a power. So x to the power of n or to the power of m. So just now we use addition, right? But this is like a whole nother level. We have to use multiplication. So we have nm. So let's take a look at some real examples. 2, and we'll use 3 here, and all squared. And 2 cubed, that's 8. And the square will remain. And 8 squared, that's 64. And another rule of thumb is that xn to the power of m, you can actually reverse the order of the power. So you can actually write that in terms of like this. This may not seem useful, but it is useful in some Olympiad questions. So this is a good rule of thumb. And for the final 3, I'll introduce the final 2 here. If you see the bases are different, but let me use m to generalize this. If the powers are the same, you can actually take out the power and it will be like one power. It just makes stuff simpler. So we have x, y, all to the power of m. So for a real example, let's use 3 here, and I'll make the bases different, but I'll make the powers the same. This is 3, right? So since the power are the same, we can actually take it out and we'll be left with 2 times 3. And since we can multiply 2 times 3 is the real number now, 2 times 3 is 6, 6 cubed, and that is 216. And there's another one for the division version as well. So if you have x over y, since the bases are the same, but then the powers are the bases are different, but the powers are the same, you can take it out, and the inside will remain just without the m's, the powers. So x over y to the power of m, and you can actually reverse this for all other laws as well. So you can have x, y to all the power of m is equal to this monstrosity. So for the final law, we have fractional powers. So what are you going to do if you have something like 2 to the power of 3 over 2? Well, you need to be familiar with square roots. So do make sure you do know what a square root is, but I'm sure you know what a square root is. So the bases will stay the same. The numerator will go inside with it. So 3 is the numerator, will go inside with it, and the 2 will go outside here. The denominator will go outside. So, but since this is a square root, you don't really need to write the 2, so I'll just leave it this way. So 2 cubed, that's the square of 8. If you want you can indeed simplify the roots. So yeah, but I won't do that in this video. So to generalize this, I use x to the power of n over m, that is equal to the bases go in with it, the numerator go in, and the denominator goes outside. So it will be equal to x to the power of n, and then it will be the root m. So the nth root of x to the power of n. So this is it for this video, and in the next couple of videos, I will, as mentioned, give some practice problems for all the laws except for the 0th power and the 1st power law, since they are really simple. So I guess stay tuned for that, and see you guys in the next video. Goodbye.